Nuclear energy is among the youngest forms of energy that humans have learned to harness, being less than 100 years old. Yet it is also among the most abundant. There is enough nuclear material in the Earth's crust to power human civilization for centuries, and yet nuclear energy hasn't really gained widespread adoption despite its clear advantages. Let's try to figure out how nuclei provide us with so much energy and what are the pros and cons of this technology. All the various forms of energy humans use ultimately get turned into heat or are some form of heat energy to begin with. For example, solar energy comes to us in the form of light, but then turns into waste heat in our electrical appliances or in the solar panel itself. Light bulbs convert electrical energy into light and into waste heat. So it stands to reason that while the principles behind nuclear energy are very complex, the way in which we use that nuclear energy is actually pretty simple. The large pipe that you see in this image is a steam tube. This tube is connected to a turbine, a large spinning fan, and it uses the kinetic energy of steam to spin at high speed, and that turbine in turn is connected to a generator which produces electricity. But where does the large amount of heat needed to create the high pressure steam come from? We can understand the how of nuclear energy with this diagram. So here we have a schematic of a nuclear power plant. Pay attention to this structure. This is where all the action happens. This is the core of the nuclear reactor, and it contains a large number of vertical rods which contain the nuclear fuel. These rods are very hot, so to keep them cool and at a safe temperature, we are pumping water into this core, which absorbs all this extra heat and turns into high pressure steam. This high pressure steam is then diverted into the turbine section, which contains the turbine, essentially a large spinning fan which takes the kinetic energy of the steam and turns it into rotational energy. This rotational energy is then fed into an electrical generator, a dynamo, which turns it into electrical energy and sends it into the grid. The waste hot water now comes out, gets cooled in the cooling tower, and is circulated back into the core where the entire process starts again. The amount of the heat generated in these plants is truly vast. A plant like this can generate enough electricity to power an entire modern city. A nuclear submarine can function for over 12 years without any need of refueling, completely independent of the surface, recycling its own atmosphere, and limited to underwater time only by the food reserves and the physical endurance of its crew. Nuclear energy has made desalinization, that is, generating fresh water from salty seawater, a practical proposition for countries with few freshwater resources. But so far so good. What is the catch here? What is the problem with the widespread adoption of this technology? Consider a heavy nucleus that is very unstable. Certain heavy nuclei are naturally very unstable. For example, U-235. U-235, when hit by a slow neutron, will break up into smaller nuclei, releasing huge amounts of radiation and heat. But what makes a nuclear reactor really click is in that the process of breaking apart, also called fission, generates, in addition to the waste barium and krypton, 3 additional neutrons, which then interact with more U-235 atoms, causing the reaction to spread and increase. A nuclear reactor maintains a safe level of fissions, allowing us to extract this energy in a useful way. This process is a million times more energetic than any chemical reaction. To give you some idea, imagine a kilogram-sized pellet of U-235 you could easily hold in your hand. That pellet of nuclear fuel can generate the same amount of heat energy as about 10,000 tons of coal, without any smoke, ash, or the storage space you would need to hold that amount of coal. The sun does even better. Rather than extract energy from the breakup of nuclei, the sun generates its energy by joining lighter nuclei into heavier ones. This process is called nuclear fusion. It is far more powerful than even fission. Here is how it works. Hydrogen has 2 other isotopes. You have deuterium, which has one extra neutron, and we have tritium, which has two extra neutrons. These two nuclei fuse together to form a helium nucleus and a neutron in the process and generate billions of times more energy than any chemical reaction. And it is even more powerful than nuclear fission. Nuclear fusion energy has allowed the sun to shine for billions of years, and fusion energy is the next major target for mankind. There are two major ways in which we are currently pursuing the production of nuclear fusion energy. One uses particle accelerators to boost hydrogen nuclei to immense speed and makes them collide together. The other uses a toroidal or a tire-shaped magnetic field to contain a hot plasma of nuclear fuel and then crush it to initiate fusion. However, to date, neither method has been able to generate usable amounts of energy. And now comes the bad news. Nuclear waste is one of the biggest problems of nuclear energy. Any nuclear reactor, no matter how clean it is in operation, will generate a huge amount of nuclear waste which can last for thousands, perhaps even millions of years. The disposal of this nuclear waste poses a major issue for all major world powers which use nuclear energy as a source of electrical energy. The other major danger is human negligence. Nearly 40 years ago, at a place called Chernobyl, a series of mistakes and serious errors of judgment caused by arrogance caused a nuclear reactor to explode. It was not a nuclear explosion, mind you, but it still flooded the region around the reactor with nuclear waste, which will remain dangerous for all forms of life for tens of thousands of years. These regions remain uninhabitable to this day, and have brought into stark relief what happens when we fail to treat nuclear energy with the respect it clearly deserves. Under correct supervision and adequate fail-safes, nuclear energy is an abundant, convenient, and non-polluting source of energy. In order to extract the benefits of this energy source, humans need to display more humility and less arrogance.
Manorama Horizon. Learning made simple.